Welcome back to Chapter 14 and 15, Introduction to Inference. This is Part 5. So here's to summarize confidence intervals. We use a point estimate, that is a statistic, and in this chapter we're using the sample mean, that is x bar, to estimate the population parameter, which is unknown, and in this chapter the parameter is mu, the population mean. We wish to construct a confidence interval with an error rate of alpha and a level of confidence of 1 minus alpha times 100. That would give us the percent. The confidence level. To quantify the accuracy and precision of the point estimate. With each specific sample, we can construct that confidence interval. As we take repeated samples, we expect that whatever the confidence level interval of the resulting intervals will contain the actual value, that percentage of the resulting intervals will contain that actual value, of the population parameter. So in other words, if we're doing a 90% confidence interval and we take these intervals over and over and over again, we create them using different samples, let's say if it was a 90% confidence interval, we would expect about 90% of the intervals to contain the actual population parameter. So the level of confidence refers to the confidence in the method, not our confidence that a specific interval contains the true value of the parameter. So an interval calculated from the data, it's usually of the form your point estimate plus or minus the margin of error. The confidence level, which is the probability that the interval will capture the true parameter value in repeated samples, that is, C is the success rate of the method. So we're going to look at a specific example. What is the average score for all young adult males for the NAEP quantitative score? So the NAEP survey includes a short test of quantitative skills, covering mainly basic arithmetic and the ability to apply it to a realistic problem. Scores on the test range from 0 to 500, with higher scores indicating greater numerical abilities. It is known that the NAEP scores have a standard deviation, a population standard deviation, equaling 60. In a recent year, 840 men between the years of 21 and 25 were in the NAEP sample. Their mean quantitative score was 272. On the basis of this sample, estimate the mean score, that is the mu, in the population of all 9.5 million young men of these ages. Use a 95% confidence interval. So we're going to construct a 95% confidence interval. So we're going to use this, the 95% confidence interval, to construct it. The sample mean is 272. Now to get the margin of error, we're doing a 95% confidence interval, so our critical value is 1.96. And now we have our standard error. It's 60 divided by the square root of how many are in our sample. There was 840 in the sample. So we took many different samples of size 840 and got different means for each of the different samples. So we can construct that many confidence intervals. And if we construct them with the critical value of 1.96, we should expect that about 95% of them will truly contain the true population mean. And here's the different ways we can interpret our problem. We estimate that the mean NAEP quantitative scores for all adult males is between 267.9 and 276.1 with a 95% confidence interval. The other way you could write it up is say something like this. We estimate that the mean NAEP quantitative reasoning score for all adult males is between 267.9 and 276.9 with a 95% confidence level. Now again, don't be misled by the statement we're 95% confident that the mean NAEP score for the population of adult males is between 267.9 and 276.1. It means we feel that plausible value for the population of males mean NAEP score are between the 267.8 or 267.9 and 276 or 276.12. That doesn't mean that 90% of all males will have that NAEP score between 267 and 268 and 276. What it means that 90% of all samples of size 840 from the population of males should yield a sample mean within 2 standard deviations of the population mean. That is, in repeated samples, 95% of the confidence intervals should contain the population mean. So for that problem, we calculate the 95% confidence interval, and here's a look at the calculation for the 90% confidence interval. As you can see, the 90% confidence interval is narrower than the 95%, as we had predicted earlier. Now this is how we would use Minitab to do this problem, example 2. The urban economist wishes to estimate the mean amount of time people spend traveling at work. He obtains a random sample of 50 individuals who are in the labor force and finds that the mean travel time is 24.2 minutes. Now, assuming the population standard deviation of the travel time is 18.5 minutes, construct and interpret the 95% confidence interval for the mean travel time to work. So in using Minitab, we go to the prompt, the MTB prompt, and we put in 1Z. Then we put in our N and our X bar. So our sample size was 50 in this problem, and the sample mean from that 50 was 24.2. Put a semicolon because we have to let Minitab know what the sigma is and what confidence level we want. So we put in our sigma as 18.5, which is given to us, and the confidence level, which is 95. We could either put 95 or 0.95. Minitab will understand both. When we hit enter, out will pop what you see at the bottom there, 1 sample Z. And you can see your confidence level in there. So we estimate that the mean amount of time people spend traveling to work is between 19.1 and 29.3 minutes with a 95% confidence interval. Here's the basic Minitab command. As I said, it's 1Z, then you put your sample size N and your X bar from that sample size, semicolon, and now we start our subcommand. We have to let it know the sigma and confidence, and once we're finished, we put a period. So sigma, you write the word sigma out and put the sigma that you're given, and then confidence and whatever confidence level. And that's all for part 5. In part 6, we'll continue on with confidence intervals.